Well, hello everyone and welcome. I was looking at Facebook here in Indie Game Developers Facebook group, and there's this guy, Ren James Cassidy Moffat. Hopefully I pronounced this right. Who wants to know, hey, I'm using physics and I want my rocket, which is being propelled up, but with a catch. The catch is I would like this rocket to spiral around the up trajectory. How might you achieve this? So I'm going to try and tackle this problem, but I'm not going to tackle this with physics because when you make games, it's all about pretending something to be true and not something actually be true. So the first thing we're going to do, so how am I going to tackle this problem then? Well, what I want to do is have, I'm going to create a new scene here. I'm going to have a rocket that goes up in a straight line, but I'm going to have a rocket model which is going to be offset slightly to the side, and it's going to rotate around that central axis. And this should sell the effect properly. Now there's one little catch, is you need to have a particle system. So that particle system cannot follow the rocket and cannot start rotating around with the rocket. So you need to have those particles be in world space and not in local space. But it's a rather quick thing to do. So let's just create a new scene here. Create scene. I'm just gonna I'm not going to like use any kind of assets for this. So you can just imagine what it's gonna look like. But let's just create a 3D object, and since a capsule kind of looks like a rocket, oops, I wanna open my new scene though. Rocket, okay. So let's create a 3D object and just call it a capsule. So this is going to be my rocket model. And I'm going to add another empty game object. So both of these objects, I'm going to put it 0, 0, 0. And then I'm going to take my rocket model and put it as a child of the game object and call that game object rocket. So he says he's propelling the rocket with physics. So let us at least do that. I'm going to add a little script that is going to be called propeller. So let's create a new script here. Let's go create folder scripts. It's not a great name for a folder. Uncle Bob wouldn't be proud, but hey, this is just for demonstration purposes. Propeller. So our propeller is going to propel in a direction. And that direction is going to be up. And it's going to propel with a certain strength using the physics system. So what I want to do here is say direction. So we have a vector 3. Oops. Let's remove this. We're going to need the fixed update, not the update. Fixed. Because we are dealing with physics, right? So, vector 3, direction. And let's make this a serialized field. And let's add a float, which is going to be strength. And let's also make that serializable so it's visible. Let's get rid of using systems collections and generics. So this is all we need. And then what we need to do is during the fixed update, we are going to do physics dot, oh, I need to actually access the rigid body here. So in awake, I'm going to say underscore RB, which is going to be my reference to the rigid body, equals get component type of rigid body. There we go. Now, writer is unhappy about RB. Let's create our field for this. There you go. Private rigid body. So now what I want to do is do RB dot and we can apply a force. So add force. And we are going to add a force along the direction vector. So direction. But this direction, I want it to be relative to my current rotation. So I need to combine my current direction with, well, the transform's current direction with this direction. Because this is going to be in world space, unless I specify that it is in local space. So I'm not sure if there is a way to say, no, there's no way to say that it's, oh, maybe it's add relative force. Yeah, add relative force. This way we can do it relative to the rigid body. And so the force is going to be direction multiplied by strength. And then the force mode is just going to be standard force. Okay, so this should be enough for our propeller. Let's see it in action. Come on. There you go. Let's go back to Unity. Let it compile. And then let's go and take our rocket here. We're going to give it a rigid body. Otherwise, this won't work. We'll give it a mass of 1 because why not? And then it's going to use gravity. All of that is perfectly fine. And then we're going to add a propeller. So the propeller is going to go up along the y-axis. So I put 1 on y and 0 everywhere else. And let's give it a strength of 100 newtons. Let's see what it looks like. Let's play. Oh. Seems like it's actually a little bit too much. Let's give it a strength of 10 newtons. Okay, that's a bit slow. But it's going up and up and up. So I guess 50 newtons. What about 50? Okay, this kind of looks like a rocket. I kind of like this. Let's zoom out. Here, I'm going to kind of put the rocket on the horizon. Take the main camera, Control-Shift-F to align the view here in the game view. Press play, see what it looks like. Okay. We could actually add to follow along with the camera. Well, not right now. We'll do that later. So, right now this is fine. Now let us say that we want the rocket to be offset, but we want to give it a spin, right? So let's add a script. We're going to call it spin. Spinner. Spinner. Spin. Well, let's just call it spin. We add spin. So here we are going to work with the update method. And I'm going to rotate it around its axis. So we are going to have a spin speed, which is going to be float, or revolutions, yeah, per second. That's fine. Revolutions per second. And let's give it also a vector 3, and which is going to be spin axis. There you go. Okay, revolutions per second. Serialized field, serialized field. And then I'm gonna just calculate the revolutions per second here in my update in terms of an angle per second. So var angle per second. We know that a revolution per second is 360 degrees per second. So all we need to do is have, if it's going to be 2 revolutions per second, it's going to be 180 degrees. So the angle per second is going to be 360 divided by revolutions per second. And then in the update method, we want to rotate it. So transform. Actually, I'm going to cache the transform because it's always better to cache your transform. Transform, the reason being that when you do form, when you do transform, when you call the transform property on an object, it's actually doing some kind of a get component on the object, which is pretty costly to do in the update. So we want to cache this in awake because the transform is always going to be the same transform. So transform equals transform. This way we get the transform here, and we're going to go underscore transform dot rotation dot rotate, and we can give it an axis. So the spin axis is going to be this spin axis, and we can give it an angle, and the angle is going to be angle per second multiplied by time dot delta time. And then we want to make sure that the space is relative to self because we want the axis to be relative to the object itself. Now, one thing that might be interesting when I look at this picture here is that the rotation speed kind of looks like it is dependent on the actual, no, it's not. Like this part here is smaller than this part here because the plane is having an upwards acceleration. I'm pretty sure that when we're lower, it's going to go faster and then it's going to go slower. I'm going to have a default revolutions per second of 4f. Kind of like that. And the spin axis is going to be by default vector 3 up. There you go. So this way it is automatically configured when I'm going to add it to my rocket. So let's add the spin to our rocket. By default, it has this. And now what we want to do is to offset the rocket model on X by a little bit. So let's offset it by, let's say 2. And let's see what happens when I press play. Okay, maybe 4 per second is not great, and maybe I can add some more offset here to make this look more obvious. And let's have 8 revolutions per second. This is not working as intended. So why am I not getting my spinning here? Can I see this? Do I rotate? Why am I not rotating? Oh yeah. No, transform, not rotate. Around the spin axis, which is the up vector. Angles per second. Multiplied by time, no delta time, relative to self. This is weird. I should have 8 revolutions per second. Oh, no, 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 no. Haha. It's not that. Angle per second, it's multiplied by revolutions per second. That's why. Okay. My bad. So I think 4 should be fine. Let's press play now. There you go. That's a lot better. So 4 revolutions per second is already pretty fast, actually. Let's go with 2. Okay, looks better. Now let's just add to my rocket model here. So the offset of 4 is a little too much. I'm going to go with 2. That's going to add a particle system to our rocket model. So I'm just going to add it as a separate object. Particle system. And obviously, first thing I want to do is saying, hey, the scaling mode is, no, not the scaling mode, where is it? The simulation space is going to be world. So this way, the rocket is going to emit in world position. And I want these particles to have 0 speed. So they're going to actually be generated exactly where the rocket is. Start lifetime 5 looks fine. I'm going to have something like a color over lifetime property, so it kind of vanishes over time, but kind of slowly. So originally it's going to stay visible, and then like in the second half it's going to slowly blend out to a 0 alpha, something like this. Maybe 5 seconds. Yeah, that means that 2.5 seconds is going to be alive. Then for the last 2.5 seconds it's going to slowly disappear. Obviously I would add some kind of a cloud thing. What about the rendering, the emission? 10 particles per second, maybe a little bit low. Let's go with 100. And let's press play, see what happens. Okay, so now you see these particles, it kind of works, but they don't look very live. So I'm going to add some stuff here just to have a size over lifetime, for example. They're going to become smaller also. So obviously I want the size over lifetime to be like more of this thing. And the initial size, the start size, I'm going to make it be 2. And also I am going to give them a little bit of a velocity. And here's going to be the little problem, is that I'm kind of going to have to give them a velocity that is going to be dependent on the position of the rocket. Because if I do this and I give them a sideways velocity, okay, but this kind of already looks good, right? So what we need to do now is to kind of make those particles drift away, but in the proper direction. So the direction in which they are going to drift is going to be dependent on the relative direction of the rocket model to the rocket. So let's add a little script that is going to do this. How am I going to tackle this? I haven't really thought about it yet. So because I can't do this directly in the particle system, it has to be kind of accessed by code. So particles scatter, I'm going to call that. And I'm going to make them scattered relative to the relative position of 2 transforms. So transform 1, reference, and private transform, offset. Those are terrible names. I'm just coming up with something here. No, that's not what I wanted to do. I want to make them serialized. Serialized. And so here, what I'm going to do is on update, I'm going to look at the direction from the reference to the offset. So this is going to be direction, var, direction equals offset minus reference. So this is going to give me the direction of the offset compared to the reference transform. And why does he like this? Oh yeah, okay, offset dot position, obviously minus reference dot position. Okay, so that's going to be the direction. I guess I can just, yeah, let's have a serialized float, scatter speed. And so we are going to take the scatter speed and multiply it with the direction's amplitude. Var speed equals scatter speed multiplied by direction. Do I need to multiply it by the direction? Let's see. First, I need to also reference the particle system. So particle system particles, serialize it as well. There we go, let's put it in the first here. And so now I can say particles dot main dot, so there's the start speed, but that's a min-max curve. Direction. Whereas, let me see here. I don't know it by heart. So we have a, where do I set the direction of the particles? I think it's in the, is it in the renderer? No, it can't be there. It's in the emitter. Shape, right? So the shape, I'm going to change the shape here to be a sphere. Sphere. And then, yeah, I can't. Inherit velocity. What is inherit velocity? Mode, initial multiplier. Inherit velocity. So what does that do? Controls the velocity inherit from the emitter for each particle. Not sure what it means. I've never used inherit velocity. Inherit velocity. Speed of particles react to the movement of the parent object over time. Specifies how the emitter's velocity is applied to particles. I think this has to be relative. This has to be relative to a rigid body, right? Particles or any simulation is set to world. Yeah, obviously. It's also possible to use curves to influence the effect over time. So, yeah, no, I can't use that to inherit velocity because I want them to stay there. So this is not what I need. What do we have here? External forces, collisions, triggers, light trails. Yeah, I think it's really about the shape. Right, so let's get the shape module dot. So what do we have here? Random direction, align to direction. Yeah, okay. Radius speed multiplier. What do we have in direction? Speed. What kind of a vector 3s do I have? Oh, yeah, I'm silly. I'm rotating the thing. So it's actually, I can just say, yeah, it's kind of silly what I'm doing here. Let's get rid of this particle scatter thing. Delete, delete, and just go here to the particle system, and so the start speed. Let's give it a speed of 0.1. I think this is good enough. And so I have a sphere here. I want the, I'm not going to use a sphere. I'm just going to use an edge. Edge is going to be perfectly fine. So right now I'm going to have a start speed of 5 just to know what direction I'm in. And I can just rotate this around the z-axis. No, not z. 90, no. Yes, 90 was fine, but minus 90. Because I'm offsetting this there. Okay. And now let's set a radius as small as I can. This is going like this. Perfect. But now the speed is just going to be 0.1. Maybe 0.5, 0.2, something like this. I'm gonna just gonna add the lifetime here. Let's make it 10 seconds. And let's press play, see what it looks like. And there you go. We have this nice thing and it's disappearing. So let's change our rocket here. I'm just going to change the strength 25 instead of 50. 50 is a little bit too much for our enjoyment. And there you go. And this kind of fades away. It looks pretty good. Let's see it in maximize on play. Now the only little problem here obviously is that my particle system is kind of centered on the model. You just need to offset it a little bit on the y axis, and well, maybe not on the y axis, because if I put it on the y, yes, no, y is fine. 0.5, no, actually 1, because it's a capsule. -1. And now this should look just about right. Okay, so there's one last little thing that's a little bit annoying. It's that the rocket should look a little bit tilted. So let's just tilt the rocket model here just slightly on the z-axis by, let's say, 10 degrees. And there you go. Now it sells the thing a lot better. Actually, 10 degrees might be a little too small. Let's go 25. There you go. I think this sells the idea pretty well. Let's go 45. Let's just go crazy about this. 45. This rocket is completely out of control. Yeah, looks a lot better, isn't it? Anyways, so this was it. Hope you liked it. Hope you learned something. And see you in another question on Facebook.